Fundamental units. In this video, we will discuss fundamental units and various units of measure used in engineering calculations. You need a specific unit if you want to measure any physical quantity. For example, if you want to know the length of a tube or area of a stadium or weight of a dumbbell, you need specific units to be added to that. Let us take an example. If I have a stone and if I say the stone weight is 10, that doesn't mean anything. When I add gram or kilogram into the stone, that makes more sense. So, a definite amount of physical quantity is taken as its standard unit. And this standard unit should be easily reproducible and internationally accepted. In other words, a unit is any standard used for making comparisons in measurements. For example, meter is a standard unit of length. Now we will see what are the fundamental units. The physical quantities which are independent to each other are called fundamental quantities, and the corresponding units are called fundamental units. The fundamental quantities are length, mass, time, electric current, temperature, amount of substance, and luminous intensity. In this chart you can see the fundamental quantities, its unit, and the symbols used for representing them. Now we will see what are derived units. Those physical quantities which are derived from the fundamental quantities are called derived quantities, and the units corresponding to the derived quantities are called derived units. For example, velocity, acceleration, force, work, all are derived units. In this chart you can see that the physical quantity, area, volume, density, velocity and acceleration, and how they are derived from the fundamental quantities. Similarly, the formula for force, speed, pressure, energy, power, all are derived from the fundamental quantities. Now we will see what is system of units. There are 4 systems of units, namely FPS, CGS, MKS and SI. FPS system, the unit of length is foot, the unit of mass is pound, and the unit of time is second. In CGS system, the unit of length is centimeter, the unit of mass is gram, and the unit of time is second. In MKS system, the unit of length is meter, the unit of mass is kilogram, and the unit of time is second. SI system contains 7 fundamental units as we seen before, and 2 supplementary fundamental units too. Those are length, mass, time, current, temperature, amount of substance, luminous intensity, and plane angle and solid angle as supplementary quantities. Let us see what is dimensions. Dimensions of any physical quantity are those powers which are raised on fundamental units to express its unit. The expression which shows how and which of the base quantities are used for representing the dimensions of a particular physical quantity. Here you can see that the distance is measured as length and its unit is L, which is a fundamental unit, and the area, which is a derived unit. The area represented in terms of fundamental unit L is L square, and the velocity is the distance by time, the combination of 2 fundamental quantity L t raised to minus 1. Similarly, here you can see how acceleration, momentum, force, pressure all derived based on the fundamental quantities or fundamental units and how it is represented. This chart shows some of the major physical quantities and its relation with the fundamental quantities along with the dimension formula and units. Feel free to pause this video and go through the physical quantities and its formula to have a better understanding. Here I have shown some of the physical quantities having same dimensional formula. For example, impulse and momentum having same dimensional formula. Work, energy, torque and moment of force having same dimensional formula. This chart really shows the mechanical relationship between units. Here you can see that the length divided by time equals velocity. Velocity divided by time equals acceleration. Mass into acceleration equals force. The energy used to do the work divided by time equals to power. Now we'll see some of the conversion charts. This is really useful when you do the engineering calculations. This chart shows multiple physical quantities and its different units and its relationship with each other. We can see example of time, length, angle, area, volume, velocity, acceleration, mass, force, work and energy, power and pressure. If you need to convert from imperial or US standard units to metric or the other way around, the table shown here should help. This is the conversion chart for length. Look closely to understand the relation between millimeter, centimeter, inch, feet, yard, etc. This is the conversion chart for area, which shows the relationship between centimeter square, meter square, feet square, yard square, acre, etc. Next is volume or capacity units. Shows the comparison between centimeter cube, meter cube, liter, ounce, gallon, etc. This is the conversion chart of mass. Shows the relationship between gram, kilogram, ton, grain, ounce, pound, etc. Next is temperature. Temperature units are Celsius and Fahrenheit. To convert from Celsius to Fahrenheit, multiply Celsius by 9/5, then add 32. Similarly, to convert Fahrenheit to Celsius, subtract 32, then multiply by 5/9. This is the conversion table of the major parameters to have a quick look. Also, you can use a lot of online calculators like the one I shown here to calculate a lot of parameters. Hope this video is helpful. Understanding all the units are really important when you come across a practical engineering problem. Please provide your comments and suggestions. Thank you.